Yeah. Okay, so today we are going to be covering two sections of your text. We are looking at section 2.5 and 5.1. So we're going to finish off chapter 2, and then we're moving on to chapter 5, the first section. Of course, chapter 2 was dealing with sets, and so we're going to finish off that 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 last section with sets, where the focus is still on Venn diagrams. And then for the second section, 5.1, we're dealing with number theory. And so those are the objectives below the line that we're going to be looking at regarding number theory. So we're looking at divisibility, prime factorization, greatest common factor, greatest common divisor, least common multiple. Okay, so that's for today's lesson. Now, we started to do some work with Venn diagrams last class, and that was part of your homework. And I gathered that you were okay with the questions that were asked. So for this section, which begins on page 88, if you have the text, we are looking at what they refer to as survey questions. And those type of questions, the Venn diagram is useful for solving and representing survey type questions. All right. So we have a diagram here on the screen that is showing you the results of a survey. So they question some persons, and basically that's what a survey is. We question persons and we get their responses. And so the diagram is showing you the results of the survey. And so we have two sets that overlap, set A, set B. And of course, I mentioned to you in previous lesson that sometimes with set, we use Roman numerals to represent regions. So these here, 1, 2, 3, and 4, those are not members of the set. They're just identifying regions within the set. All right, so it says the results of a survey are summarized in this figure. So set A shows students willing to donate blood. Set B, students willing to serve breakfast to donors. Okay, and so you will see 1, 2, 3, 4 different numbers here. In the intersection, we have 120 inside of A, but outside of the intersection is 370. Inside of B, but outside of the intersection is 220. And then outside of the circles altogether is 290. So they're asking some questions. The first question is, how many students are willing to donate blood? So basically, sorry, just a second. Hello? Hello? I'm good, sir. Okay. Everything is okay though, because I have a class, so I can't talk long. I told them Monday. Why they brought it today? All right. Well, let them put it in the foyer for now, because yeah. Uh, okay. Just yes. Okay then. All right. All right. Sorry about that. Okay. Okay. So set A, it says how many students are willing to donate blood. So the circle that represents persons donating blood would be circle A. So basically then we are looking at the entire contents of A, which, oops, sorry. If you look at A, and this is set out in your book on page 88 going to 89. So the entire A would include the 370 and the 120. So that would represent the amount of persons that are willing to donate blood. And so that number would be the sum of those two, which in this case is 490. Okay. Then, okay. Now your book have several other questions, which I don't have on the slide. So that was part A. So if you look on page 89, part B is asking how many students are willing to help to serve a free breakfast to blood donors. So the person's willing to serve free breakfast, what portion of the circle would that represent? Of the Venn diagram, which regions? Let me ask Miss Nairn.
That would be regions 2 and 3.
Okay, regions 2 and 3. So you will simply add the numbers in regions 2 and 3, which would be 120 plus 220, which gives you 340. Okay. So the next question for C, which is in your book on page 89, they ask how many students are willing to donate blood and serve breakfast. Let me see, Miss La Rochelle. What's the answer to that one?
Region 2.
Region 2. Okay, so that would be the region where there's the overlap. Okay, and so in that region we have 120. So the answer for that would be 120. Okay, so we have next here Miss Fernanda. Question D is asking how many students are willing to donate blood or serve breakfast. Ms. Fernanda? Ms. Fernanda, are you there? Okay, Miss Pratt, can you answer that question? I don't see Miss Fernanda.
How many students are willing to donate blood?
How many, the question is, that's D. It says, how many students are willing to donate blood or serve breakfast?
So would that be? Would that be the 370 plus the 120? And give us a
Okay.
total.
Okay, it says, how many persons are willing to donate blood or serve breakfast? So you still have something missing there. You only give me a
And the
part of
120. So it'll be the 370, 120, and the 220.
right. Okay. So once we use that word or, it includes everything in the circles shown. Okay. So if you're donating blood, or you're serving breakfast, or you're doing both, that would be all three regions there, which would be region 1, 2, and 3. So you'd add all three together to get the total. And so in this case, that total should be 710. Okay. So thank you, Ms. Pratt. All right. So we have, okay. Now that was D. So let's go to E. So E asks how many are willing to donate blood but not serve breakfast. Miss Fernanda, you back with us? Miss Fernanda?
Hi, sorry about that. I had an internet issue just now.
Okay, yeah. This part E is asking how many are willing to donate
You're still
blood?
breaking up a little bit.
Okay. The question is on the screen. See if you could answer that question. How many are
Okay.
willing to donate blood but not serve breakfast?
Okay, donate blood. Okay, so that would be the 370 minus the 120.
Well, why would you minus the 120?
Because they are willing to serve breakfast and blood. Serve give blood, donate blood. Would it
okay,
be?
but that 370 is not included in the persons who want to donate blood. Sorry.
Oh, sorry.
That 120, that 370, those persons are the persons willing to donate blood, but they are not in the circle for those willing to serve breakfast.
Yes. Oh, that's true. So it's just the 370. Sorry.
Right. So it's just that 370. So how many people are willing to donate blood but not serve breakfast? That would be just the section A in this case. Okay. So that would be 370. Okay. And then we have F. Now for F, which is in your book, it says, how many students are willing to serve breakfast but not donate blood? So we go back to, let me see, go back to Ms. Nairn. How many students are willing to serve breakfast but not donate blood? That's F.
Okay, that'll be 220.
220. Okay, thank you. And then let's see, go to the next one. G, how many students weren't willing to do either? Anybody could answer that. How many students were not willing to do either?
290.
290. Okay, because they didn't fall in any of the circles. All right, so that's what that 290 represent. And then the final one, H, how many students were surveyed? What do we know? How would we find that? How many students were surveyed? How could we decide that?
Add all the regions together.
Add all the regions together. Thank you. All right. So if we add all the regions together, it would be 370 plus 290 plus 120 plus 220. And I think the total for that is, according to your book, is 1,000. Okay. All right. So I give you a couple minutes to look at this one here. Okay. So this is checkpoint 1, similar type of thing. So it says here, let me see if I could enlarge it a bit. It says here that in a survey on musical taste, respondents were asked, do you listen to classical music? Do you listen to jazz? The survey results are summarized in figure 2.27. Use the diagram to answer the following questions. So of course, in the diagram, you have two circles overlapping, classical music, jazz, and you could use that to answer those questions. So go ahead and answer those, please. Okay. So there's the number. Okay, so I'm going to ask each of you to answer two. I'm going to start with Ms. Nairn. The first two questions, Ms. Nairn, A and B. Can you tell me what your answer is, please?
Okay, for A, 75.
Mm-hmm. Okay.
And for B, 90.
Okay. Thank you much. All right. Thank you. All right, Ms. La Rochelle, I want you to answer C and D, please.
For C, it's 20.
Mm-hmm.
And for D is 145, I think.
Thank you. That's correct. Okay, Ms. Pratt. Could you answer E and F?
Okay. How many respondents listen to classical music but not jazz? 55.
Mm-hmm.
And F, how many respondents listen to jazz but not classical music, which is 70.
Okay, thank you. And then Miss Fernanda, the last two, G and H.
Okay, G is 30,
Mhm.
H is 175.
Okay, thank you very much. Very good, all of you. Okay then. All right, so I'm gonna move back then to, all right. All right, so what we did just now, we were just basically using the Venn diagram to answer questions. So now in this section, which is on page 90, you're going to be given a question and you're going to use the Venn diagram or represent the situation using a Venn diagram. So they give you some steps to solving survey problems. The first step is to use the service description to define sets and draw a Venn diagram. Then you're going to use the results to determine the cardinality of each region. And of course, by cardinality, we mean the number of members in each region. And then we normally start with the intersection. That's the innermost, and we work outward. Okay? And then we can use the complete Venn diagram to answer any questions relating to the problem. So we're going to look at an example here. And this one is a little bit long, so it entails a few slides. So this example is found on page 90 of your text. So it is saying that a survey is taken that asks 2,000 randomly selected US and American adults the following question. Do you agree or disagree that the primary cause of poverty is societal injustice? And so the results are shown. It says the results of the survey show that 1,060 agreed with the statement. So these 1,060 are saying that the primary cause of poverty is societal injustice. And then it says 400 Americans agree with the statement. If half the adults surveyed were Americans, how many Mexicans agreed with the statement? How many Mexicans disagreed with the statement? Okay, so before we could answer questions A and B, we first need to represent the diagram, represent the problem using the Venn diagram. I mean, there can be other ways to do it, but since we are dealing with Venn diagrams, we're going to represent the situation using a Venn diagram. And so your book goes into a little detail as to how you could go about that. And so I'm just going to follow the order that is shown. Okay, so the question talks about US and Mexican adults. And so, and the results are persons who agree with the statement. It says 1,060 agreed with the statement, 400 Americans agree with the statement. So you will see then that they have used a Venn diagram. They have identified the 4 regions, 1, 2, 3, and 4. Okay, so set US is the set of Americans surveyed, and that set A, labeled agree, is the set of people surveyed who agreed with the statement. Okay, the area outside the circle represent the set of Mexicans. Okay, the group of people outside of circle A must be the set of people disagreeing with the statement. Okay, so A, agree. US would be the Americans. And then outside of that would be your Mexicans, according to how they have it set up here. So the area outside the circle represents the set of Mexicans. So we move on then. It says you determine the cardinality of each region in the Venn diagram, starting with the innermost region. And so based on the way the question is worded, it says there were 2,000 people surveyed. So that's the total number. So when you add up everything, you should get 2,000. Then it says half the people surveyed were Americans. So of course, if half of 2,000 is 1,000, it also tells you that the number of people who agreed with the statement was 1,060. Then it says to you that there were 400 Americans who agreed with the statement. Okay, so those are some of the numbers that we have. So now it says you're going to start with the innermost region and move outwards. Of course, the innermost region is in our diagram is region 2. So you see the step by step. So the first diagram, they fill out this 400 because those are the persons who are Americans who agree with the statement. So this circle here represents Americans, and this other circle represents those who agree. So the Americans who agree is equal to 400. Now, of course, we saw where it was 1,000 Americans. So we already put in 400 in the circle here, the circle that represents Americans, and the circle that represents agree. So the remaining, since it was 1,000 Americans, you subtract the 400 from 1,000, and so that's how we got this 600. Okay. And then here it says that the number of people who agree to the statement is 1,060. So the circle for agree, which is circle A, should have 1,060 in it. We already put 400 in the intersection. So therefore, it would need another 660. If you subtract 400 from 1,060, you get 660. So this section then would be 660 to complete this total of 1,060 for that circle representing those who agree. And since we have a total of 2,000 persons, we only accounted for 600 plus 400 plus 660. And so we need to make sure if that doesn't add up to 2,000, we add this up. If it doesn't add up to 2,000, we need to find out what we need to add to that total to get 2,000. And in this case, it was 340. All right. So when they added up those three, they got 1,660. And so when you subtract 1,660 from 2,000, you get 340. So that would represent the persons outside of the circle. Okay. So now that we have all the regions filled out, we can now answer the questions that were asked. The first one, the Mexicans who agreed with the statement are shown in region 3. Okay, because region 3 does not include Americans. All the Americans are in either region 1 or region 2. That whole circle of 1,000 represents the Americans, and they only interviewed Americans and Mexicans. So if you're not in the American circle, that means you have to be a Mexican. So in this case, then those persons who agreed with the statement belong to region 3 because those Mexicans who agreed with the statement belong to region 3 because that's the only region where you have agreement which are not Americans. So that would be that region. And so that's 660. And the second part asks the Americans who disagreed with the statement. So again, circle US is only for persons identified as Americans. Everything outside of that would be Mexicans. So within this circle A, those persons agree. So outside of the circle would be the persons who disagree. And in this case, all the persons in that area would also be Mexicans because all the Americans fall in the circle marked US. And so,
Miss
sorry.
Allen.
Yes, ma'am.
Hi, I'm trying to follow. I'm trying to figure out why they didn't label one of the circles as Mexican. They have as A for American and US.
Mm-hmm.
why one of the Venn circles isn't labeled as a Mexican if we have questions that relate to Mexicans in reference
Because,
to Venn?
okay, so let me go back. Let me go back here. Okay, so because of how the question is worded, we are told 400 Americans agreed with the statement and 1,060 persons agreed with the statement. So the overlap is not between Americans and Mexicans. Okay, the overlap is between those who agree, okay, who are Americans, and those who are not Americans. So that's why we didn't have a circle for Mexicans. You have to look to see what intersection do we have? What is in the intersection of the two groups that we are looking at? So if the statement was worded in such a way that you had Americans and Mexicans and you were told that a certain number of the two of them agree, then you would have an overlap between the Mexicans and Americans, but it wasn't worded in that format. I don't know if I'm making sense there.
Yes.
Okay, so you have to look at the question and see, in this case, because we're trying to do it as a Venn diagram and we're looking for overlap, then we have to see what is in the overlap or in the intersection. And that's how we determine how we're going to set up our Venn diagrams and label them accordingly. Okay, let me go back here. All right, so we have, oh, okay, well, this one, they actually gave you the diagram, so I was going to go through it, but in this case, for checkpoint 2, they actually set the diagram up for you, so you don't have to decide how to set it up. So what you need to do then is just decide how much to put in the various region. So this one says in checkpoint 2, in a Gallup poll, 2,000 US adults were selected at random and asked to agree or disagree with the following statement. Okay, job opportunities for women are not equal to those for men. The results of the survey show that, it tells you that 1,190 people agreed with the statement, 700 women agreed with the statement. Okay, if half the people surveyed were women, how many men agreed with the statement? How many men disagreed with the statement? All right. So again, this is a situation where you weren't really given numbers about men and women. The focus was really on the women and those who agree with the statement. So you can deduce from the way it is shown here that a portion of this would be men, but as far as the information given from the question, their focus is on women and women who agreed with a particular statement. And so that's why they have the Venn diagram. One represents women, and one of the circles represent those who agree with the statement. Okay, so there was no information about men per se, but we can deduce from the diagram, once we finish labeling it, what the sentiments of men are in the survey. So let's look at this now. So what is going to go in the intersection in this case?
700.
Okay, so 700, and why you say 700?
Because 700 are women who agree, so that fall into both in both regions 1 and 3.
Mm-hmm. Okay. Everybody else in agreement with that?
Yes.
Yes? Okay. All right. So we say 700. Now, let me see if I could put that 700 in here. Okay. So 700 women agree. So the women and those who agree would be 700, would be in this in the intersection. Now the next part, section 1, region 1. What should go in region 1? Who said 700? Who was that? I didn't get your voice.
Fabian.
That was Fabian? Who said 700?
That wasn't me.
That was
No, it was
Naren.
Naren. Oh, okay. So Miss La Rochelle then, what should go in region 1? Hello?
Sorry, just reading it. 1 second.
Okay. First, we need to know how many women were involved in this survey. How many women were involved in the survey, Ms. La Rochelle?
It only says 700 women agreed. It didn't say how much women there was in total.
Okay, how many persons did they survey in total, according to the question? I didn't hear you.
1,000.
I thought, how much you said?
1,000 was selected for the survey.
At the top, in the first line.
It say 1190 agreed with it.
No, the first line and here, this
Yeah.
first line. How many persons were involved in the survey?
8,000.
Oh, 2. Okay, I didn't hear the 2. Okay. Now, look at this here. What does it say here? You see where I'm underlining?
Oh, okay. So the total, what will go in the woman's slot is 300.
Okay. So it's a half were women. So, well, it wouldn't be in the women's slot, but it would be in the women who in region 1.
Yeah, in region 1.
Yeah, region 1. Okay. Because for women, the total is actually 1,000. So the 300 would complete that circle. All right. Ms. Pratt, what would go in region 3?
Those who agreed.
I didn't hear you.
Sorry. How many men agreed? How many men?
Okay,
What am I looking at?
you're looking at region 3. Okay, that circle with A is telling you how many persons agreed. Okay, now it says 700 women agreed with the statement, but 1,190 persons agreed with the statement. So we have 2 numbers we're looking at. 700 women agreed, but 1,190 persons agreed. So we need to know what should go in region 3. We already have region 2 filled out.
490.
490? Okay, so 490 would make up the balance of that circle to give you a total of 1,190. Okay, so now Ms. Fernanda, what is the total number of persons in the survey?
Yes.
How many persons involved in that survey?
Pardon?
How many persons involved in the survey?
2,000.
2,000. So the numbers we have there now, the 300, the 700, and the 490, does that add up to 2,000?
No. So we would have to find the persons that didn't agree.
Okay. So how are we going to do that?
So we would have to add together all the persons in the regions, and then subtract the total. That'll be that all those would add up to 1490. And then we would subtract that from 2000, and we would get 510.
510. Okay, so right here you should have 510. All right, thank you. So now, based on what we have in this diagram now, we can answer the two questions that follow. The first one says, how many men agreed with the statement? How many men agreed with the statement? Anybody could answer.
490.
490. Okay. 490. And how many men disagreed with the statement?
510.
510. Okay. All right. So that's it for that particular question then. Okay, so next we are looking at back to page 92. Constructing a Venn diagram for a survey. We kind of did that just now, but I think at this point now we're going to move on to look at the three intersection of three circles. Okay, so basically it's the same thing. We're going to use the service description to define the sets, draw the Venn diagram. Then we're going to start with the innermost region and work outwards. And then we're going to use the completed to answer questions. So in this example, we have it says here, 60 people were contacted and responded to a movie survey. And so they have information. The first part says 6 people like comedies, dramas, and science fiction. Okay, so that's the first thing there. And then it goes on now to tell you that 13 people like comedies and dramas, 10 people like comedies and science fiction, 11 people like dramas and science fiction, 26 people like comedies, 21 like drama, and 25 like science fiction. So in this type of question now, I can't remember who asked the question about why didn't we use Mexicans and Americans. In this question, they actually give you identify the 3 areas straight off right here: comedies, dramas, science fiction. And they tell you the number of persons that fit into all 3. Okay, so that's clear. That's a clearly defined area that is identified. So here we're going to use C for comedy, D for drama, S for science fiction. And so straight off, 6 people like comedies, dramas, and science fiction. So those people would fall in the innermost. Okay. And once we know that region, then we can work from there to fill in the rest of the regions. Now you see a little study tip on the side right here, which is saying to you, after entering the cardinality of the innermost region, work outward and use subtraction to obtain subsequent cardinalities. And of course, by cardinality, we mean the number of elements or members in the set. Okay, and then they use the phrase survey subtract. This is a helpful reminder of these repeated subtractions. So the next one, B, says 13 persons like comedies and dramas. Now, this whole section here, represents comedies and dramas, but we already have 6 in that section. So how many more do we need to put in this region right here so that we could complete the number of persons that like comedies and dramas?
7.
7. 7 and 6 is 13. So we subtract the 6 from the 13 and we get 7. Then it says 10 people like comedies and science fiction. So comedies and science fiction would be right here. So we already have 6. So we need another 4 in this region to get 10. And then it says 11 people like dramas and science fiction. So dramas and science fiction would be right here. Dramas and science fiction. So we already have 6. 6 and 5 gives you 11. So 5 goes here. So we have partially completed the diagram. Now we are going to the next set of regions. It says 26 people like comedies. So comedy would be this circle marked C, the whole circle. We already have 3 sections filled out. 7 plus 6 plus 4 gives us how much?
17.
17. So how many more we need to fill in that circle for comedies?
4.
17 plus something
9.
gives us 26.
9.
9. Okay, so that should be 9. Oops. Okay. And then we now have 21 persons that like drama. So what's going to be missing right here to fill in the drama circle?
Three.
Okay, 18 and 3 gives us 21. Okay, because 7 and 6 is 13, 13 and 5 is 18, 18 and 3 gives you 21. And then the last section they have here says 25 people like science fiction. So we have 6 and 4, 10 and 5, 15. So we need another 10 to complete that. Now, we're not quite finished because we have to make sure that we get 60. 60 people were contacted. So we need to add up what we have here to see if it equals to 60. So let's see now. 10 and 4 is 14, 14 and 9, 23, 23 and 7 is 30, 30 and 6 is 36, 36 and 5 is 41, 41 and 3 is 44. So what are we going to do?
Put the balance on in the universal.
Okay. So what's the balance in this case?
16.
You said it was
16.
44. Yeah. Okay.
16. Okay. So 16. So 16 people did not like comedies or dramas or science fiction. Okay. So those would fall on the outside of that set, those 3 circles. And so that's how we represent the question using the Venn diagram. So we start with the innermost. A lot of people make the mistake where it says in B, 13 people like comedies and dramas, they go and put the 13 where that 7 is. No, if you put 13 where the 7 is, then that 13 and 6 would give you 19. So that would be 19 persons falling in that instead of 13. So you once you put that innermost region in, you subtract and you keep subtracting until you fill in all the regions, and then you check to see if all of what you filled in equal to the total that's involved in the survey. And if they're excess, then you put them on the outside of the circles. Okay, so let's try one. So we have checkpoint 3 here. And it says that a survey of 250 memorabilia collectors showed the following results: 108 collected baseball cards, 92 collected comic books, 62 collected stamps. And then they list the different subsections. They want you to fill in the Venn diagram to show the results. So I give you a couple minutes to work that. Then I'll call on you to tell me what you get. One, two. Okay, so I have the diagram label in as eight regions. So I'm going to call on each of you to answer two regions. Let me see, where's my sheet with the names. Okay, so Ms. Nairn, I start with you. Region 1 and 2. Tell me what you have in those two regions.
Region 1, I have 2.
Mm-hmm.
Region 2, I have 3.
Now my region 2 is at the top.
Oh, I have 27. Hold on.
27.
So the first region for you is baseball cards?
No, the first region for me is the people that fall in all three.
No, I mean the first circle.
Oh gosh, I just realized something. Oh, yeah, I should have, okay, I should have made sure that we're all on the same page. I didn't do that. Yeah, so I should have, I have B for baseball cards, C for comics, and at the bottom I have S for, what do I have S for again? What's that?
Stamps.
Stamps, yeah, that's how I have it. Now,
Okay.
some of you might have it different.
Yeah, okay, so region 2 will be 27.
27, thank you. Mm-hmm. All right. All right. So your diagram don't have to be labeled like mine, but just as you answer, just see if you could match up with what I have there. So that was Miss Nairn. So Miss La Rochelle, if you could identify where my 3 and 4 is, tell me what you got for those two. Miss La Rochelle, are you there?
For 3, I have 59.
59.
And for 4, I have 5.
Okay, now let me see. So how, explain how you got that 59.
3 would be 1, 2, 3. Okay, I got the 59 because it says, where is it? It says 92 collected comic books.
Okay, for my 3, we're looking at baseball cards and stamps. So we start off by saying
It's baseball cards and stamps. So isn't that 3?
Are you looking at the diagram I have here?
Comic books only, you have that label as 3, right? Or that's something else?
No, you see where I have 3 is right here in the intersection. Between base B and S. We already put in 2 in the middle. So I just need to find out what else needs to go in this portion right here that let me put my cursor on so you could see where I'm talking about. Right here, this is where I need between baseball and stamps, this region right here. So we already have 2 in the middle, but we need to find out how much more needs to go right in this section.
That'll be 5.
But, well, the total is 5. The total is 5.
3.
Because it says, right, so you just need 3 more to complete that, right? Okay, so remember you have to subtract from what's there. So there's 3 and 2 gives you 5. And then for region 4, is this little portion right here. We already have 2. So how much more we need to fill this out? You see that region, Miss La Rochelle? Right here, region 4.
Isn't that already there? It said 2 collected comic book and stamps.
Okay, but we already have 2 up here. So what should go here?
Do we put another 2?
No, that would make it 4.
0? I don't know.
What can you add to 2 to get 2? Miss La Rochelle? What can you add to 2 to get 2?
Nothing?
0. So you should have a 0 right there. You follow?
Yeah, 0.
Okay. Yeah. You said 0, but you sound like you were asking a question. That's why I continue to, you know, because you sound like you weren't sure when you said the 0. But yeah, 2 and 0 gives you 0. All right. So that's it for that section then. All right. So now we're going to section 5 and 6. So Miss Pratt, tell me what you have for 5 and 6. Miss Pratt, you with us?
I'm here. I just realized you have the thing on you had my diagram.
Okay, so 5 would be the rest of section of baseball cards. The rest of the count for baseball cards. How many more you need to fill out that circle for baseball cards?
Baseball cards is would it be 17?
How many in total collected baseball cards, according to the question?
Oh, sorry, 108.
108. But we already have some numbers in there.
Yeah, sorry, I
So,
was looking at the wrong amount for baseball. I have 72.
You're off by something. Not 72. You're close to it, but you're not quite there. You have to add the 27, the 2, and the 3, and take that away from 108.
76.
76, right? Okay. So the next part I need you to answer me now, Miss Rat, is section 6, which is right here. That's the people who collect comics. How many more we need to fill out that circle based on the number of persons that collect comics in total.
Two.
Okay, let me hear how you get that 2,
Okay,
because
so 92 collected comic books. So we have to add the 27 plus the 2. Oh, sorry. 90?
It's not 90. When you add the 27 and the 2 and the 0, what you get?
The 27 and the 2. 27 and the 2 will give you 29.
Right, and you're going to take it away from
90.
you're taking it away from 90.
92?
Yeah, you're taking it away from the.
Am I correct?
How much you get?
29 take away from 92 give you 63.
63. Yeah, that's it.
I understand, you know, Mr. Allen. It's just that how you have to bend this label.
Yeah, I realized I made a mistake. I should have told you all how to label it so that we could all be on the same Yeah. So I'll do that for future, but let's look at, okay, so that was Miss Pratt. So Miss Fernanda, the last two for you.
And
So section 7 would be the circle S for stamps. How many more we need to fill in that section?
the section, that'll be 57.
5, 7, right? And then outside of all the circles, section 8,
22.
22. All right, thank you. All right, so basically then we're following that process of identifying where is the intersection of all three. And then we look for the regions where it's 2, subtract from that to fill in those regions. Then we look for the information that tells you the total amount in the set or in that circle. And then you have to add up what's already in the circle and subtract it from the total. And then once you finish all the circles, then you add up the total amount in all the circles and you subtract from the total amount in the survey to find out how many persons did not choose any of the items within the circles, that the sets that were highlighted. Okay, and so basically we're just looking at the representing the information in the Venn diagram, but you should also be able to answer questions about it. So we didn't look at answering questions, but here we're going back to look at example. One of the questions we looked at earlier where we put the information in the Venn diagram. So this is the one that deals with comedy, drama, science fiction. So in this case, they're asking you some questions. So the first question they ask you here, you have the Venn diagram, C for comedy, D for drama, S for science fiction. And they're asking you, how many of the persons surveyed liked, and then it says comedies, but neither drama nor science fiction. So they have the diagram label 1, 2, 3, 4. Okay, they have it regions. Okay, so how many persons, Ms. Nairn, what do you say to that? How many like comedies, but neither drama nor science fiction?
That would be 9.
Okay, 9, right. Okay, so this one would be 9. And of course, the detailed answer for this is in your book on page 93. And if you want further details on how they get the answers for that. Thank you, Ms. Nairn. Okay, Ms. La Rochelle, let's look at B. How many persons like drama and science fiction, but not comedy? Hmm?
5.
5, okay. So drama and comedy, sorry, drama and science fiction. Okay, drama and science fiction. So this is drama here. This is science fiction, but they want the persons who like drama and science fiction, but not comedy. So this 6 here represents those who also like comedy, but they don't want the people who like comedy. They just want the people who like drama and science fiction. So that would be this 5 right there in region, that's region 6. So that's 5. Okay, Miss Pratt, the next question is asking for those who like drama or science fiction, but not comedy.
Drama or science fiction.
But not comedy.
So that'll be 8.
Okay, let's see. drama, that's this, or science fiction, that's this,
Oh, so we
but
have to count up.
not comedy. So they don't want anybody who fall in the comedy circle. But if you do drama or science fiction, yes, count me. So which regions would that be?
3 and 4.
It says or drama or comedy. Sorry, drama or science fiction. So you still have another region. 3, 4. No, you said 3 and 4? No, it wouldn't be. No, it wouldn't be 3 and 4. You see, this is 3.
Yes.
This is what you're talking about? Or
Yes.
you're talking about this 6. This is 6. 5 and 1,
Oh,
6.
sorry. Okay.
Mhm.
So that'll be
So
8 and 12.
yeah, but you still have another region. Remember, it says drama or science fiction. So if I say or science fiction, that means if I like science fiction, you have to count me in too. Which other?
You mean 10?
Okay, so that's the 10, the 5, and the 3.
18.
18. Okay, right. So drama or science fiction, but not comedy. So once we use the word or, that means you could fall here, there in the intersection, or there. We don't want anybody who like comedy in this answer, just the people who like drama or science fiction. So it would be the 10, the 3, and the people who fall between the two of them. So that would be 18 in total, yes. Okay, now that was Miss Pratt. Okay, Miss Fernanda, look at D. They said people who like exactly one movie style.
So that'll be the 9 in section 1. The 3 in section D. Section 3, and then in section, the last one is 10.
Okay.
So
So
that's
when you
22.
add that up, 22. Okay, thank you. All right, so those people only like one. So it would be, as she said, this one here, they only like comedy. These people only like drama. These people only like science fiction. So you add those 3 together, and that gives you the answer for D. Now look at E. It says, how many persons like at least 2 movie stars? What do we mean by at least 2?
Only 2?
At least 2.
So that'll be the persons and like the persons with the one with 4, 7, and 5.
What about the one with 6?
No, come on, that's the 3.
Yeah, but it said at least 2.
That'll be 3. At least 2. Okay, so yeah, I understand.
Yeah. So when I say at least 2, that means it could be 2, it could be 3. Okay, anything from 2 up. So you would have to add those 4 areas.
Yeah.
So it would be 7 plus 4 plus 5 plus 6. 7 and 4 is 11, and 5 is 16, and 6, that's 20. Okay. So for E, you would be adding all of those, and that answer happens also to be 22. And of course, the last one everybody should see is equal to what? None of the movie styles. 16. Okay, so they don't fall in any of the. Okay. All right. So this Venn diagram is the Venn diagram that we did for checkpoint. I think that's checkpoint 2. I want you to use that diagram to answer these questions that follow. So I give you a minute or two to look at that, and then I'll call on you. Checkpoint 4. which is on page 93 of your book.
Mr. Allen, can you give me a few minutes, please? I just have to swing my son to school.
The school. Okay, who is this?
This is Miss Pratt. I'm
Pratt.
still on. I'll still be on. It's just that can't pay attention to the screen for a few
Okay.
minutes.
Okay then. All right. Okay, so you're out of it. Okay.
I can sit right here and wait tomorrow for you. You hear me?
Hello. Hello. Somebody was saying something, or oh. Okay, so let's look at these questions. Okay, so I'll call on Miss Nairn for A and B.
So for A is 63.
Mm-hmm.
So for B, I had a question. When it says baseball cards and stamps, that's they're speaking about the area that likes those two only, or the area that only likes baseball cards, or area that only likes stamps, and then collectively.
Okay, so it says baseball cards and stamp, but not comic books.
Mm-hmm.
So baseball card and stamps would be right here.
Right. So it was
But not comic
3.
books.
So
Right.
3. But I was
Mhm.
just wondering if I was supposed to include the 76 and the 57.
Now, if it said or,
Oh, okay. So the answer is 3.
yeah. So and means that they fall within the intersection of the two, or means that once you fall in one set, the other set, and in the intersection, you count it. That's what the or means. Okay.
Okay.
All right. So that was, what was that again, Miss? That was Miss Nair. I was speaking with just now?
Yes.
Okay, okay. All right. 1, 2, 3, 4, 5. Okay. All right, Miss La Rochelle, I think she said she had to step out a bit. Let me double check. Okay. All right, so let's go to Miss Pratt is out. Okay, Miss Fernanda. Miss Fernanda?
You said this is C?
C and D, yeah. Tell me what you got for C and D.
Okay, for C I got 136. And for D I got 30.
Yeah, wait again, chapter 4.
Okay, Miss Allen, I'm here.
This is Miss Pratt.
Yes, it
Okay.
is.
Okay, you're back. Okay, okay. All right. So I was looking at C and D. You said 136, and what was your other answer?
30.
30. Okay, yes, yes. Okay. All right, so that's correct. That was Miss Fernanda. Okay. Okay, Miss Pratt, can you answer E and F?
Okay. So at least one type of memorabilia. So it'd be 76 plus 27. Okay, for E, do you have 231?
Tell me what you did.
I added all of the sets because it said at least one.
Mm-hmm.
So I added the 76, the 27, the 63, the 3, the 2, and the 57.
Okay. I mean, you did the right thing, but your calculator did something wrong.
Let me go back.
And what you said you got?
231.
Okay, yeah. You probably add something twice. Double check it.
Sorry, 228.
Okay, right. And then the last part says none of the types of memorabilia.
22.
22. Right, thank you. Okay, so that brings us to the end of our look at the chapter on sets. Next week, we have another quiz, which will look at this last part, along with what we're going to do on this section on number theory. The first quiz that you did, like I said, you will get the result a little later on, and we'll go through it. There are 1 or 2 things that I think we need to review. And so we'll look at that a little more towards the end of the lesson. So for the rest of the time, we're going to begin chapter 5. Chapter 5 is starts on page 228 of the book, for those of you who have it. Let me find that, chapter 5. 5.1. Okay, 228. All right, so we did start a little bit on this number theory when we were doing sets. Thank you. So number theory, it says here, is primarily concerned with properties of numbers for counting. And the counting numbers are the same as the set of natural numbers. Natural numbers are numbers, oh, the diagram didn't come out too right here. Okay, the commas got misplaced, but you should be able to see what said numbers starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. Okay, so that's basically what number theory involves, operations and the properties of those type of numbers, a set of natural numbers. Natural numbers are also called counting numbers. The natural numbers that are multiplied are called the factors of the product. Okay, so they give some examples of what they're referring to here on page, this is on page 228. Okay, so you have 2 times 12 is equal to 24. So 24 is the product, and the numbers 2 and 12 are factors. Of course, there are other ways you could multiply, other numbers you could multiply to get 24, 6 times 4, 3 times 8. Oh, they have them here. Okay, yeah, all right. So they have 3 times 8 is 24, 6 times 4 is 24. So those numbers that you multiply to get 24 are called factors of 24. And of course, the answer is referred to as the product. Anytime you multiply, the answer you get when you multiply is called the product, and the numbers that you multiply to get the product are called the factors. Okay. Now, first thing we're looking at here is what they refer to as divisibility. Now, of course, when you see divisibility, what word comes to mind? When we see the word divisible, what word comes to mind?
Divide.
Divide. Okay, so it has to do with something with divide. Yes. Okay, so it says if A and B are natural numbers, and natural numbers we say are numbers starting from 1, 2, 3, and so on. If A and B are natural numbers, A is divisible by B. That means A can be divided by B if the operation of dividing A by B leaves a remainder of 0. So once the remainder is 0, we can say that A is divisible by B. So we're going to look at some practical examples. This is just a general statement about divisibility. This is the same as saying B is a divisor of A, or B divides A. Okay, so we're going to look again. All right. All 3 statements are symbolized by writing B divides A. So the symbol is shown here. You put a, I don't want to call it a slash, but it's a dividing line between A and B. Is a vertical slash, not a leaning slash. Okay. So you see some examples here. We write 12 divides 24, because 12 divides 24, or 24 divided by 12 leaves a remainder of 0. 24 divided by 12 gives you 2 with no remainder. 24 is divisible by 12. All right, so in another example, if the question is asked, is 13 does 13 divide 24? Or is 24 divided by 13, you will not get a remainder of 0. 13 can go into 24, but you're going to get a remainder, which is not 0. Okay? So it doesn't give you a remainder of 0, so therefore the statement is not true. 13 does not divide 24. So you see that a stroke is put there to indicate that it does not divide 24. All right? So they wrote this here, but this is not true. 13 does not divide 24. Even though 13 can go into 24, we say it doesn't divide 24 because it doesn't give us a remainder of 0. Okay? So just some study tips that should be found. I think it's page 229 of your book. So the word factor and divider mean the same thing. 8 is a factor and a divisor of 24. That means 8 can divide 24. So we use the word factor and divisor to mean the same thing. Another study tip, they say do not confuse B divides A with B slash A. The symbols are different. So you will see B divide A, that's a vertical line. It's different from, sorry, B divide A like that. Okay, so one is like a fraction and one is just a statement as to whether or not B actually divides A. So they have two different meanings. Okay, so be careful when you're writing that symbol. Now on page 229, you will see what is called a divisibility table. And these can be useful for when you have to do mental math, because a lot of work that we have to do with divisibility, because we are using calculators, we can easily find out whether or not one number is divisible by another. When you divide, if you don't get a remainder, if you get a whole number as your answer, then you know that it's the first number is divisible. Sorry, the second number is divisible by the first. But sometimes it is useful to have a mental knowledge so we can do our work more quickly, more easily. Sometimes you don't have a calculator available. You can decide whether one number is divisible by another simply by following some basic rules. And so they have the rules for 2, 3, 4, 5, 6, 8, 9, 10, and 12. Well, everybody should know the divisibility rule for 2, because, as long as a number is an even number, we know it's divisible by 2. And you can know if a number is even because the number ends with 0, 2, 4, 6, or 8. So any number that ends with 0, 2, 4, 6, or 8, we know it's divisible by 2. So if you try to divide by 2, your remainder will always be 0. For 3, the rule is that when you add up the digits in the number, it gives the result is divisible by 3. So in this number that they have here in this example on the side, they ask you if 52,341 is divisible by 3. If you add up the digits, 5 plus 2 plus 3 plus 4 plus 1, you get 15. 15 is divisible by 3. So because 15 is divisible by 3, it means the number 52,341 is also divisible by 3. Okay? So, and you could always check, just go on your calculator and say 52,341 divided by 3, and you should get an answer that is a whole number. You won't have any remainder. For 4, it says the last 2 digits is divisible by 4. So once the last 2 digits of the number is divisible by 4, the entire number is divisible by 4. And the example is shown there. Everybody should know 5, and everybody should know 10. So We don't need to discuss that. With 6, it says the number is divisible by 2 and 3. So it means that the number has to be even and the sum of the digits must be divisible by 3. It'll have to fit the 2 rules. Once the number fits the 2 rules, then it's divisible by 6. For 8, it says the last 3 digits is divisible by 8. So if you could divide the last 3 digits of the number by 8, then the entire number is divisible by 8. So they give you this big number in the example for 8, 593,777,832. And they just looked at the last 3 digits, which is 832. Once that is divisible by 8, the entire number is divisible by 8. And then for 9, you are using, what do they use here? Okay, they're saying the sum of the digits is divisible by 9. So it's kind of similar to 3. In the case of 3, we said the sum of the digits is divisible by 3. In the case of 9, the sum of the digits is divisible by 9. So when you add up all the digits, you get something that's divisible by 9. The entire number is divisible by 9. And then for 12, it has to fit the rule for 3 and 4. So the digits are divisible. When you add up the digits, it's divisible by 3, and the last 2 digits are divisible by 4. So if both rules are satisfied, the number is divisible by 12. Now, like I say, you don't really have to memorize these. Some of them you should know. You should know 2. You should know 5 and 10. Everybody should know those. But the rest, it will be helpful to know from time to time, especially if you have to do mental calculations. It's helpful for quick mental calculations. So we're going to look at some questions here. In example 1, they're asking you to say whether or not the following are true by looking at the rules. Okay, so the first one is asking you, does 4 divide 3,754,086? And the rule for 4 is that the last 2 digits must be divisible by 4. So the last 2 digits for this one is 86. Now 486, 482, and 406. So you're going to get a remainder. So therefore, that one wouldn't be divisible. So of course, then it means that that is false. Okay. The next one, they ask you if 9, okay, they put the symbol here. 9 does not divide. It's a little, let me see. It's a little kind of hidden, but the symbol is saying 9 does not divide 4,119,706. Sorry, 119,706,413. So now, in order for you to know if it's divisible by 9, we look at the rule for that. The sum of the digits is divisible by 9. So, we're going to have to add up all those digits. Okay. So I'll just look at the answer here. So you have to add the 4, the 1, the 1, the 9, the 7, the 0, the 6. It'll be quicker to just use your calculator and try dividing by 9 and see what happens. Okay. But when you add them up, you get 36. And 36 is divisible by 9. So it's not true to say that 9 doesn't divide that number, because 9 does divide it. So that's why they have false here. And then the last one they have here is 8 divides 677,840. So the rule for 8 is the last 3 digits forms a number that's divisible by 8. So we're going to look at that one. The last 3 digits is 840. 8 into 8 is 1. 8 into okay, so 8 into 4 is 8 into 40. So this last one is divisible by 8, the last 3 digits. So therefore it means the entire number is divisible by 8. So it's true. Okay. So I want you to look at these here. You could either use your calculator or you could use the rule. The rules that's given to you on page is that again? Page 229, and answer those 3. Give you a minute to do that. State whether they are true or false. Let me see. Miss La Rochelle, are you back?
Yes, I'm back.
Okay, okay.
All right.
Okay, so let me see who's Miss La Rochelle. All right, so tell me what you have for A.
I have false.
False. Okay. So the last 3 digits, yeah. Okay, that's false. Yeah. Thank you. Okay. Let me see. Okay, that's Mr. Rochelle. Miss Pratt, what you have for B?
True.
True. Yeah. Okay. And Miss Fernanda, what you have for C?
False.
False. Okay. Thank you. Okay. So now we have the next section deals with prime numbers and prime factorization. Now, a prime number is a natural number greater than 1 that only has itself and 1 as factors. What's the first prime number? What's the first prime number?
3.
Okay, why you didn't say 2?
I remember 2.
You don't remember 2? Okay. But look at the rule, what it says. It says a prime number is a natural number greater than 1 that only has itself and 1 as
Two is a
factors.
prime number.
So would
Correct.
2 be a prime number?
It's a prime number.
Yes,
It
2
is
is
a
a prime
prime number
number.
because it only have 1 and itself as factors. So we could start with 2, then 3. What about 4?
No.
No.
What about 5?
Yes.
Yes.
Yeah, definitely not 6. What about 7?
Yes.
Yes.
Definitely not 8. What about 9?
Yes. No. No.
No,
Yeah.
no,
Yeah.
no, no.
Because then
No.
3.
3.
Yeah.
3 was 3.
So, okay, 10. What about 11?
Yes.
11. What's the next one then after 11?
13.
13. And then 17. Then 19. Then 23. And so on. Okay. So that's the first set of prime numbers we have there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's look at the 10th one. What about 25?
No.
It's 20. What about 27?
Yes. No, 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 sorry.
What about 29?
Yeah.
Yeah.
Okay. All right. And so on. That's the first 10 prime numbers there. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, but of course we could go on. Okay, so they only have two factors, one and the number itself. And of course, 2 is a prime number. So therefore then, we have this other term, composite. So a composite number is a natural number greater than 1 that is divisible by a number other than 1 and itself. So what's the first composite number?
4.
4. Okay. And the next one will be
6.
6. Then
8.
8. Then what's the next one? We're going to the first 10. 8.
10.
Then before 10, there's another one.
9.
9. Okay. Then 10.
12.
12.
14.
14.
16.
15.
15. 16. 1, 2, 3, 4, 5, 6, 7, 8. Now, what's the next one after 16?
18.
18. And so we could continue on and on. All right. So if you don't count 1 in it, 1 is neither prime nor is it composite. But when you count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so if the number is not prime, then it's composite. All right, so any number that's not prime is composite, but we're not counting 1. 1 is not prime, nor is it composite. So when we're looking at the set of natural numbers, if you don't include 1, the number is either prime or composite. So the ones that are not prime are composite, and the ones that are not composite are prime. Okay, so now they have this, what they call the fundamental theory of arithmetic. Every composite number can be written or expressed as a product of prime numbers in one and only one way. Okay, so that is useful because sometimes that is helpful when we want to do certain things, certain calculations. All right, and so one method that we use to find the prime factorization of a composite number is to use a factor tree. Now, we don't have to worry too much about the prime factorization of prime numbers because it's only 2 factors, 1 in the number itself. But with composite numbers, they have more than 2 factors. And so sometimes it's useful to be able to write them as a product of their prime factors. And so to find the prime factorization of a number, we could use the factor tree. And so we're going to just look at a review of that because I think most of you should have done something similar before. So we start with any 2 numbers whose product is equal to 100, to 700. All right. So in this case, we start with 700 and 7 times 100. And once we have a prime number, we could, circle it or underline it or identify it somehow. So 7 is a prime number. So we don't have to divide that 7 any further because you can't break it down any further because it's only 1 and 7 that could divide 7. So now 100 could be divided to 2 times 50. 50, 2 times 25. 25, 5 times 5. So once we end up with only prime numbers, now we can find the prime factorization of 700. Now, even though we started with 7 times 100, you should note that a number of numbers, you may have different ways to start. Because on the side here, we have 700 is equal to 5 times 140. So even if we start with 5 times 140, at the end of the whole factor tree, the order of the prime numbers may be different, but it's going to be the same result. So here we have 5 coming twice. Here we have 5 coming twice. So we have the 2 5s here, but in this one, we have the 5 here and we have the 5 there. In this example here, we have 2 appearing twice. Right here, we have 2 appearing twice. And then here we have a 7 once. Here we have the 7 once. So it's the same result, just a different order. And so in the fundamental theory of theorem of arithmetic, it says every composite number can be expressed as a product of prime numbers in one and only one way. So the order may be different, but in the end, it's the same result. Okay? So no matter how you start, so you don't have to start with 7 times 100, you don't have to start with 5 times 40, but whatever two numbers you multiply to get 700, once you continue until you get only prime numbers at the end, the result will be the same. All right? So once we do the prime factorization of 700, we're going to get that's equal to 7, based on what we had here, 7 times 2 times 2 times 5 times 5. So they have it here, 7 times 2 times 2 times 5 times 5. So all we have here is prime numbers. Once we get only prime numbers, we are finished. So we write it now in shorter form, 7 times 2 to the second power times 5 to the second power. And then they rewrite it as 2 in order, 2 to the second power times 5 to the second power times 7. Now you notice here, they use dots to represent multiplication, but when we are writing it, we don't use dots, we use a multiplication sign. We only use the dots when we are typing or in textbooks, all right? But when we are writing, we use the multiplication sign, okay? So the dot represents multiplication, but like I said, that is usually for typing purposes. And we finish off by arranging them from smallest to largest. So let's try this one. I want you to do the prime factorization of 120 using what we just looked at as an example. I give you a minute to work on that.
Okay, Google, all products or factors of 120. Okay, Google, all factors of 120.
Okay, so let me see. Um, Okay, Ms. Pratt, tell me what you started with. Hmm?
Oh goodness. 3.
3 times what?
3 times 3 times 40.
Mm-hmm. Any of those are prime?
Only 3, not 40.
Okay, so we circle the 3 because it's prime. All right, so the 40 could be broken down now to what?
You have several amounts that can go into 40.
Just choose one, it don't matter.
You can say 5,
5 times.
8,
Okay, any of them prime?
5,
Okay. And then the 8.
you can say 4 or 2, but none of them are prime.
4 times 2, okay. Any of them prime?
No.
Mm,
Oh,
which,
sorry,
what's
2.
the
Sorry, 2.
2?
2.
Okay, all right. And so how are we gonna break the 4 down?
Um, 2. You can say what? 2 into 4.
What I want two numbers to multiply to give me 4.
2 times 2. We have 2. Well, we already have 2
2
there.
times
2 is 4.
2. Okay, any prime numbers there?
Only 2.
2 and 2. So we can't go any further. So once you have, so all your numbers are prime, so you're gonna say 120 equals 3 times 5 times 2 times 2 times 2. So if you write that in order, what would you get?
We would put 2. I'll tell you right now. Let me go by. We would
Hmm?
put 2 to the 3rd power
Mm-hmm.
times
Times.
3
Mm-hmm.
times 5.
Times 5. Okay, you could always check your answer. 3 5 is 15. 2 times 15 is 30. 2 times 30 is 60. 2 times 60 is 120. Okay. Now you don't have to start with 3 times 4. Anybody else start with a different combination?
I did.
What you started with?
5 times 24.
Okay, so 5 times 24. Let's go that one and see. 5 times 24. So that's 120. 5 times 24.
And
And
then
okay.
and
Mm-hmm.
I did 2 times 12.
2 times 12. Okay.
And
And then
then 2 times 6.
mm-hmm.
And then 2 times 3.
2 times 3. All right. So you still end up here. They got a 5 times 2 times 2 times 2 times 3. So if you put that in order, you're still going to get 2 to the 3rd times 3 times 5. Okay. Anybody else did a different order?
I did.
What you did?
I have 5 times 24, but then
5
I
times.
went and I did 3 times 8.
Okay, so 5 times 24,
And
then 3 times 8, and then the 8 would be 2 times 4,
2 times 4,
then 2 times 2.
and then 2 times 2.
Okay. So in the end, you're still going to get 2 to the third times 3 times 5. So that's that fundamental theorem. Basically, no matter which route you take, once you end up with prime numbers, it's going to be only one result you're going to end up getting. Okay, every composite number can be expressed as a product of prime numbers in one and only one way if the order of the factors is, arranged in ascending order or descending order. Okay. So you should be able to get the gist of this then. We identify the prime numbers, and once we end up with all prime numbers, and we can't break it down any further, then we write it as a product of its prime factors, and that's your prime factorization. Now, the prime factorization is useful when we want to solve certain problems, and some problems it's helpful when you can find the greatest common divisor or the lowest common multiple. And so we're going to look at greatest common divisor, lowest common multiple, and solving problems using those two principles. Now, one way to do the greatest common divisor is to use the prime factorization of numbers. Okay, so it says here the greatest common divisor of 2 or more natural numbers is the largest number that a divisor or factor. Let me read that again. The greatest common divisor of 2 or more natural numbers is the largest number that is a divisor or factor of all the numbers. And they say, for example, 8 is the greatest common divisor of 32 and 40 because it is the largest number that divides 32 and 40. Some pairs of numbers have 1 as their greatest common divisor set. Such number pairs are said to be relatively prime. So if you were given 2 numbers and the only number that you could divide both of them by, the largest number is 1, then we say that those numbers are relatively prime. Okay, and so they give some examples. 5 and 26. The highest number that could divide 5 and 26 is 1. So therefore, we say that they're relatively prime. Okay. Sorry. Okay. So they going through the process now of how to find the greatest common divisor of numbers. Now, some pairs of numbers, you can just look at them and figure it out mentally. But if you can't figure it out mentally, one approach is to first write the prime factorization of the numbers. Then it says select each prime factor with the smallest exponent that is common to each of the prime factorization, and then form the product of the numbers from step 2. And the greatest common divisor is the product of these factors. So it makes more sense when we do an example. So we have this example here where you're given 216 and 234 to find the greatest common divisor. So you're going to write out the prime factorization of each. So for 216, you see we have 2 times 2 times 2 times 3 times 3 times 3. And then for 234, we have 2 times 3 times 3 times 13. Okay. And so once we have those, they have the prime factorization simplified here for 216, and the prime factorization simplified here for 234. So now what they ask you to do is select each prime factor with the smallest exponent that is common to each of the prime factorizations. So the ones that are common is 2 and 3. So we have 2 in both of these, and we have 3 in both of them. We only have 13 in one of them. So the greatest common divisor then, we're going to look for 2 and 3. Those are the ones that are common. And then it says choose the one with the smallest exponent. The exponent is the power, these powers. So in the case of 2, we have 2 to the third and 2 to the first power. You don't see anything there, but if there nothing is there, it means to the first power. So we're going to take the 2 by itself, which is 2 to the second. And then you have 3 to the second and 3 to the third. The one with the smallest power is 3 to the second. And so once we take those, then we're going to multiply them. 2 times 2 to the first times 3 to the second would be 2 times 3 times 3. 3 times 3 is 9. 2 times 9 is 18. So the greatest common factor of 216 and 234 is 18. So that is telling you that 18 is the greatest number that can divide 216 and 234. Any questions with that? No? Okay, so let's look at this one then. We have 225 and 825. So let us start with 225. Anybody want to suggest what we could do for 225 to break it down? What numbers could we use? When you look at that number, you should be able to see right away which number can divide 225. 5. We know we could start with 5 because 5 definitely could go into that. 5 times what gives you 225?
45.
5 times 45. Okay, 45. So you could circle this 5 because that's a prime number. Okay, now when you 45 could be broken down to
5 again.
5 times
9.
9. Okay, prime number here. And then the 9 could be broken down to
3 times 3.
3 times 3. So that's the end of that. Okay, so 2, 2, 5 is equal to 5 times 5 times 3 times 3, which would be equal to 3 to the second times 5 to the second. Now, the next number is 825. We should be able to use 5 again because the number ends with a 5. 5 times what gives you 825?
165.
Okay, that's 165. We could break that down using 5 again because right away, 5 times what gives you 165?
33.
33. So that's a prime number. Okay, now how could we break down 33?
11.
Oh, 11.
3 times 11. Okay. 3 times 11. Okay, I didn't put this here. Okay. Okay, so we have all prime numbers. So we say 825 is equal to 5 times 5 times 3 times 11. So when we simplify that, we should get 3 times 5 to the second times 11. Now, we want to find the greatest common divisor. So GCD equals. Okay, so which prime factor is common to both of them?
5 and 3.
Okay, so it's going to be 3 times 5 because we don't, 11 is not common. Now, which of the 3 has the lowest power? 3 to the first or 3 to the second?
3 to the first.
Okay, which would just be the same as 3. And which of the 5s have the lowest power?
5 to the second.
5 to the second. So the greatest common divisor then would be 3 times 5 times 5, which is equal to what?
75.
75. Thank you. Okay. So that's the result of that. Any questions with that? Okay, so we're moving on then. All right, so here we're looking at solving a problem using the greatest common divisor. So the common divisor by itself is useful if we can use it to solve problems. We also use it sometimes when we have to do work with fractions. Okay, but problem solving is one of the uses of it. And it says here, the greatest common divisor can be used to solve problems where we need to divide larger groups into smaller, evenly distributed groups. So we have this question here where it says, for an intramural league, you need to divide 40 men and 24 women into all male and all female teams so that each team has the same number of people. What is the largest number of people that can be placed on a team? Okay, so this is one example of the type of problem we could solve using the greatest common divisor. Let me see. Okay, so if we want to solve something like this, let me see, this is on page 233 of your book. All right, they go into a little bit of detail there. So what we're trying to do is find the largest number of people that could be placed in a team, but we want each team to have the same number of persons. So if you want to have teams, that means if the male team have 5 members, the female team must also have 5 members. But we want it to be the same number. So therefore, you're looking for a number that can divide 40 as well as 24. Now, something like this, you should be able to look at it and figure it out. Anybody could just look at 40 and 24 and tell me what is the greatest common divisor?
4.
No. 8.
8.
Okay, yeah, 8. All right. So sometimes you can mentally work out a problem like this by just looking at the numbers, especially if the numbers are fairly small, and figure out what number is the largest number that can divide both. Okay. And so even though the book gives you this method of using the factor tree and doing the prime factorization, another method that people use, but it can be tedious if you have large numbers, you could list the factors of 40. So I could say factors of 40. What are the factors of 40? Equal. What are the numbers? We know definitely is 1. What other numbers can divide 40?
2.
2. Mm-hmm.
4.
4. Mm-hmm.
5.
5. Mm-hmm. Mm-hmm.
10.
Okay, before 10, there's another one.
8.
8 and 10.
10. Mm-hmm.
And 40?
Okay, we have 2 more before 40.
20.
20. We have 1 before 20. Hold on. Okay, 20. Yeah. And 40, I think. That's it. Let me see. 3 times 5 times 16. Okay. Yeah, I think that's it. And then the factors of 24 would be what? Definitely 1. Mm-hmm. What else?
2.
2. Mm-hmm.
3.
3. Yeah.
4.
4. 6.
6. Yeah.
8.
8. Mm-hmm.
12.
12. Yes.
24.
24. Okay. So now since we have the factors listed and we are looking for the greatest common divisor or the greatest common factor, we could look at them and see which ones are common. 1 is common, 2 is common, 4 is common, 8 is common, and that's it. Which one is the greatest?
8.
8. So the greatest common divisor or the greatest common factor equals 8. Okay, but when you have large numbers to deal with, it's not so easy to identify all the factors. So that's why that other method is useful. So if you have 40, let's see if we could do that. 40, break it down into 2 times 20. That's prime. This would be 2 times 10. Then 2 times 5. Okay. So 40 would be equal to 2 times 2 times 2 times 5. And what's that? Okay, then 24, let's break that down. That would be 3 times 8. This is prime. That's 2 times 4. That's prime. And then this would be 2 times 2. So 24 would be equal to 3 times 2 times 2 times 2. So 40 would be 2 to the third times 5. And this would be 2 to the third times 3. That's 3. Okay. So now, if we're using the prime factorization method, which factor is common to both of them?
2.
2.
And 5.
No,
No, sorry, just 2.
2. So we said the greatest common divisor equals 2. And which of them have the lowest power of 2? Which have the lowest power of 2?
They have the same power as 3.
So it's 2 to the third. All right. So 2 to the third is equal to 2 times 2 times 2. And what is 2 times 2 times 2?
8.
Equals 8. Okay. So if you use the factorization method, the prime factorization method, you get the same answer. But like I said, because the numbers are fairly small, you could either just list the factors out, or you could work it out mentally. But when you get large numbers, like if you had 400 and 860, it might not be so clear right away. So it would be good to write as a prime factorization first, then look for the common factor and then write down the common factors with the lowest power, multiply them out, then you get your greatest common divisor. So the answer to this question, what is the largest number of people that can be placed on a team? 8. So the men team, how many groups of 8 would you have? If you have 40 men. How many groups?
Repeat the question, please.
Yeah, since it says here, what is the largest number of people that can be placed on a team? Since we have 40 men, and they're saying, we said the greatest common factor is 8. How many male teams would we have?
Oh, so we'll divide 40 and
By 8, yes. So we'd have how many teams for the men?
5.
5 male teams, okay. And then how many teams would we have for the women?
6.
6 8s?
24.
6 8s are 48.
Oh, sorry.
We only have 24 women.
3.
3. Okay. Now the question didn't ask you how many teams. They only want to know what is the largest number of people that could be placed on a team. So the answer that they're looking for is 8. 8 is the largest number of people that could be put in a team. But sometimes the question may ask you how many male teams, how many female teams. So if they'd ask you that, then you would say you'd have 5 male teams with 8 members each and 3 female teams with 8 members each to give you equal sets of teams. Okay. All right. So, oops. All right. So I want you to look at this checkpoint here. So this one is not as straightforward to figure out the greatest common factor. So I give you a few minutes to do that. I'll give you 2 minutes to start the process, and then we'll look at it. So it's a similar type of question to the one we just looked at. Okay, LCM. Okay, Ms. Fernanda.
Still working.
Yeah, tell me what you're doing so far.
Okay, for 192, I'm factorizing, and I did 3 times 64. And then I broke it down from 64 is I put 8 times 8. Then I did 2 times 4 for each of those 8. So that'll be 2 times 4, 2 times 4. And then for the 4s, I did 2 times 2 and 2 times 2.
Okay, so that's gonna give you 3 times 2 times 2 times
2
2
to the 5th power 3 times.
2 to the 5th times 3. Okay. Thank you, Miss Fernanda, right? Yeah.
Yeah.
Okay. Miss La Rochelle, tell me what you did for 288. Miss La Rochelle? Oh, she's there.
I'm still, because I joined the class back late due to the power outage, but
Oh,
I don't know if
288.
I don't know if I did it right, but I have 8 by 36, then
8 times 36. Okay, 6 8 is 48. 3 is 24. Yeah, okay.
and 9 by 4, and then 2 by 2.
2 by 2? 2 by 2.
9 by 4, and then 2 by 2.
No, 2 by 2 wouldn't be for 8. 8. When you break down 8, what are you gonna get?
Oh, 4 by 2.
Okay, 4 times 2. So put that prime, and then you said for this one you get 4 by 9 for 36. 4
Yes.
9. Okay, 4 times 9. All right. So this 4 could be broken down to
2.
2 times
2.
2 times 2. Okay, good. And then the 4 here would be 2 by 2 again. And the 9 would be
3 by 3.
3 by 3. Okay. All right. So 288 then would be equal to, let's see, what are the primes we have here? 2 times 2 times 2 times 2 times 2 times 3 times 3. Let's see, I have 1, 2, 3, 4, 5. And then 3. Okay. So when you break that down, that would be 2 to the 5th power times 3 to the 2nd power. Okay. Okay, thank you, Miss LaRoche. Miss Nairn. So we want now to find the greatest common factor, greatest common divisor for these two numbers. So we have 2 to the 5th times 3, and we have 2 to the 5th times 3 to the 2nd. So what we're going to do?
So I mean, oh, you mean what the next step will be?
Yeah.
Okay, so then we would use the 2 to the 5th power because that's the
Okay, very
greatest
good.
divider.
Well, it's common, and the 5 is the lowest power, yeah.
Right.
And then, are we going to use the 3?
Oh, and then we'll say no.
We're looking for all the common factors, and we're using the lowest power of each.
Oh, okay. So yeah, we'll just put 3.
Okay. Why not 3 to the 2nd?
Because that's the lowest.
Okay, the lowest power is the one, just 3 by itself. Thank you.
Right.
So when you multiply this out now, what you're going to get? 2 to the 5th times 3.
Is it 96?
You're telling me or you're asking me? I want you to tell me.
Okay, hold on. 1. Sure, I think it's 192. I get different stuff every time I calculate it.
So tell me what you do to calculate it. What are you doing?
But I was
You're
saying
just,
2 times 2 times 2.
but you have to do it 5 times. 2 times 2 times 2 times 2 times 2. You're multiplying 2 5 times, then times 3. So if you want to do it the long way, you could say 2 times 2 times 2 times 2 times 2 times 3.
Okay,
So
192.
okay, so 2 times 2 is what?
4.
2 times 4 is
8.
2 times 8 is
16.
2 times 16.
32.
And 32 times 3?
96.
Mm-hmm. Yep. So answer is 96. All right. So the question asks, what is the largest number of people that could be placed in each singing group? So what's your answer? What's your answer? Miss
It's not-
Nia?
96.
96. You sound like you're not sure though.
I sure 96.
96, yeah, 96. Anybody want to tell me how many male groups? The question didn't ask this, but I'm asking you, how many male groups could we get if we have 96 members in each team, in a singing group?
2,
2. What about the female group?
3.
3. Okay. So we'd have 3 groups of 96 for the women and 2 groups of 96 for the men. Like I said, the question didn't ask this, but just in case they asked. So all they want to know, what's the largest number of people that can be placed in each singing group? The answer is 96. Okay, thank you then. We're going to move to the next concept, which is the lowest common multiple. All right. So the lowest common multiple is 2 of 2 or more natural numbers is the smallest natural number that is divisible by those numbers. So with the greatest common divisor, we're looking for the greatest number that can divide the numbers. Now we are looking for the smallest number that is divisible by those numbers, okay? So we can also use prime factorization to help us define LCM. But in the same way, we can sometimes mentally figure it out. We could do the same thing with LCM. And sometimes we could just list the multiples and identify the lowest common one. But if it's a large number, sometimes it might not be so straightforward. So it's good to be able to use the prime factorization method. So it says you are to select every prime factor that occurs, raised to the greatest power to which it occurs. So we'll look at an example to see how that works. So they give you an example here where you have to find the least common multiple of 144 and 300. So we're going to do the prime factorization of 144. We get 2 to the 4 times 3. So we didn't do the actual 3, but if you do the 3, this is what you would get. And then for 300, it is 2 to the second times 3 times 5 to the second. So what they do, when we were doing the HCF, what we would do, we'd look for the common one. So the common one is 2, and the common one is 3, and we look for the lowest power of each. But when it comes to the LCM, we're not looking for what's common. We're looking for all of them. So we look at the 2 sets of factors. So we look at 144, we have a 2, we have 3. 300, we have 2, we have 3, we have 5. So we're going to take the highest power of each. So if you look on this section here, oops. Oh, anyway, you're looking for 2, 3, and 5. We only circle the ones with the highest power of each factor. So we have 2 on both lines, but the one with the highest is the 2 to the 4th. We have 3 on both lines, but the one with the highest is 3 to the 2nd. We have 5 on this one, but we don't have a 5 here. But once it's a factor, we're going to circle it. And so the lowest common multiple then would be the 2 to the 4th times 3 to the 2nd times 5 to the 2nd. Okay. And so we work that out. 2 to the 4th times 3 to the 2nd times 5 to the 2nd. 2 to the 4th is 16. 3 to the 2nd is 9. 5 to the 2nd is 25. And so we multiply that out, we get 3,600. So the LCM of 144 and 300 is 3,600. So that's the smallest number that is divisible by 144 and 300. And so, oh, we have a simple one here to look at in checkpoint 5. Now this one, let me see. You may be able to decide what's the lowest number that 18 and 30 could divide. Anybody could figure that out by just looking at them? No, 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 no. You giving me the greatest common divisor. I want the lowest common multiple. When we're doing the lowest common multiple, it's going to be bigger than those numbers that's there. When you get the greatest common divisor, it's going to be either equal to the smallest or smaller than the numbers. But with the least common multiple, it has to be a bigger number than, yeah. So now one way we could do this, we could write out the multiples of 18. So 18, 2 times 18 is what?
9.
Okay.
Sorry. 2
Let me write
times
it.
18 is 36.
Multiples of 18. So I hear 18, 36. Next.
54.
54. Next.
72.
72. Next.
90.
Next.
108.
108. Okay. So I'll just stop at a few. Now look at multiples of 30. Multiples of 30 equal 30,
60 and 90.
60, 90. What else?
120.
Do we really need to go any further?
No.
No,
Yeah.
because 90 is
Wow.
LCM.
Okay, 90 is the LCM. We're looking for the lowest common. So the first common multiple we find is what we're looking for. So the 90 is common and it's the lowest one. None of the other multiples are common. 72 is not common, 54 is not common, 36 is not 18. Neither is 30 and 60. So we could stop right there. So one way to deal with the least common multiple, if you can't figure it out mentally, you could just write out some of the multiples of the numbers until you come up with one that's common to both, the lowest common one. All right. So you could either work it out mentally or write out the multiples. But other than that, you could do the prime factorization. So you could say 18. What numbers multiply to give you 18? Anybody? Give me 2 numbers that multiply to give 18. 2 factors of 18. Oh, I have to call a name in. Okay, let me see. Miss
2
Pratt.
times 9.
2 times 9. Okay. So this is prime, and then 9 could break down into
3 times 3.
3 times 3. Okay. So that's the end of that. So that would be 2 times 3 times 3, which is equal to 2 times 3 to the second power. Okay. And then the next number we have is 30. Now let's see how we could break down 30. 30 would
3
be equal
times
to
10.
3 times 10. Okay, that's prime here. And then
2
10
times
would be
5.
2 times 5, and that's prime. So we finish with that. So that's equal to 3 times 2 times 5, which is equal to 2 times 3 times 5, if you put it in order. Okay, so when it comes to the LCM then, we are going to look for each factor and take the highest power of each. So what are the factors that we have in these two? We're looking at this, and we're looking at that. What are the different factors we have?
2, 3, and 5.
Okay, so we have 2. And what's the highest power of 2?
Just 1.
Okay. And then what's the highest power of 3?
Second power.
Okay. And what's the highest power of 5?
Just 1.
Okay. So when you multiply this now, 3 times 3 is
9. No,
9.
yeah, 9.
Okay. So the answer then, 2 9s are,
18.
and 5 times 18?
90.
90. All right, so the LCM is 90. So we could either do this multiples method if the numbers are fairly small, but if you have large numbers, it's best to use the factor tree method. Identify the prime factorizations and then look for each factor and take the highest power of each. Okay, so now we're going to move on then to look at problem solving using the lowest common multiple. So it says that the lowest common multiple can be used where you have to find an overlap of two or more activities. So in this case, we have a question where you have this theater that it says it runs its films continuously. One movie runs for 80 minutes and a second runs for 120 minutes. Both movies begin at 4. When will the movies begin again at the same time? So it's 80 minutes. Then again, it's going to be 80 and 80 is 160. Then 3 times 80 gives you what? 3 times 80.
240.
240. Then going to 4 times 80 would be
320.
320. Then we go one more time, would be
400.
400. So the movie that goes for 80 minutes, this is the sequence. Okay, so you're going to start at 0, then you're going to do 80 minutes, you're going to start again. 160 minutes, you're going to start again. 240 minutes, you're going to start again, and so on. Now, the one that's going for 120 minutes, so you start there, 120 minutes, you're going to start again. Then what's the next time?
240.
40.
Okay, then next time would be
360.
360, and so on. So we're looking for when will the movies begin again at the same time? Based on what you see here, when is it going to be?
240.
Okay, after 240 minutes. Okay, so that is finding the LCM. So we could actually work out the LCM and we get that answer, but we could list the multiples of 80 and 120, which is what we just did, and look for the lowest common multiple. Okay, so it says both movies begin at 4 p.m. When will the movies begin again at the same time? It will begin 240 minutes after 4 p.m. Oh, what time would that be? 240 minutes after 4 p.m. How many hours is 240 minutes?
4 hours.
4 hours? Okay, so what time would that be if you started at 4?
8.
8 p.m. Okay, all right. So it would be 8 p.m. when the movies begin again at the same time. All right. So you could have actually done the prime factorization and find the LCM for both. You would still get that same 240. And oops, all right, I wrote over that. But anyway, in your book, you'll see the same thing on page 235. And okay, they did the prime factorization here. So 80 is that, 120 is this. And so they take out all the common, all the factors, not the common one, but all the factors. So it's 2, the highest power of 2 is 2 to the 4th. Then 3, the highest power of 3 is just 3 to the 1st power. Highest power of 5 is 5 to the 1st. When you multiply that out, you get 16 times 3 times 5, which is 240. So that's 240 minutes. Okay, therefore it will take 240 minutes or 4 hours for the movies to begin again at the same time. By adding 4 hours to 4 p.m., they'll begin again at 8. Okay, so, all right. And just what we did here, it says example 6 could also be solved by making a partial list starting time of the movie. So you start at 4 and 80 minutes would be an hour and 20 minutes. So you next one would be 520, 640, and so on. All right, sort of similar to what we did. And then you'll see the first time when the two begin at the same time was 8 p.m. All right, I'm not going to look at number 6 here. I'm going to move on to this slide in the interest of time. But, okay, let me see. All right, So I want you to look at these 5 questions, and it's 2. So the 2 statements say greatest common divisor can be used to solve problems where we need to divide a larger groups into smaller, evenly distributed groups. The lowest common multiple can be used where you have to find an overlap of 2 or more activities. All right, so I wanted to look at these 5 questions here and see if you can decide whether you're going to use the greatest common divisor or the lowest common multiple to solve them. So I wanted to read them, and I'm going to call on you to tell me what's your thought on them. You know, I don't want you to solve it. I just want you to, based on what it is saying, tell me whether you should use a greatest common divisor. And the greatest common divisor is when it seems as if you want to divide a larger group into smaller groups, and whether you should use an LCM, which is when you you're trying to find when 2 or more activities will overlap. Okay, I'll just give you a couple minutes to read through those. Okay, Ms. Nan, what do you say for number 1?
I say that's the greatest common divisor.
Why? Is it
Because
asked? Okay, listen to the thing. Greatest common divisor, you're looking for your cases where you have to divide a larger group into smaller, evenly distributed group. LCM is asking when you're going to find an overlap, so 2 things end up being the same, more or less.
oh, sorry, it's LCM because we're trying to determine where the 2 bars could be the same height.
Right, right. Okay.
Yeah.
So that's the case for number 1. So anytime you're trying to get 2 things to be overlapping or be the same at the same point again, then you're looking basically at a problem that you can use LCM to solve. Okay, thank you, Miss Nan. Miss La Rochelle, look at number 2. Tell me what you think for that one. Miss La Rochelle, are you there?
Will that be the lowest common multiple?
Okay, that's number 2. So that one says a math teacher combines his class with a science class for a group activity. The math teacher has 18 students and the science teacher has 27 students. The teacher wants to form groups of the same size. Each group must have the same number of math students and the same number of science students. What is the greatest number of groups the teachers can form? So look at the 2 things that's at the top. The greatest common divisor can be used to solve problems where we need to divide larger groups into smaller, evenly distributed groups. The lowest common multiple can be used where you have to find an overlap of 2 or more activities. Which one you think is more appropriate for question 2?
The greatest common divisor.
Okay, we are trying to form smaller groups from those 2 groups. You have 18 students in one class, 27 in another class, but they want to form groups of the same size. Each group must have the same number of students, okay? And they want to find the greatest number of groups that each teacher can form. So that's a question where you would have to use the greatest common divisor. Okay, Miss Pratt, number 3. What you say about that one?
Least common multiple.
Okay. Let's read that one. A manager at a restaurant can buy hamburger buns in packages of 8 and hamburger patties in packages of 6. Suppose the manager cannot buy part of a package. What is the least number of packages in each product? You can have an equal amount. Okay. All right. So we're trying to find some kind of overlap there. Okay. So we're looking for the LCM. Okay. Okay. Where are we now? Number 4? Miss Fernanda?
Yes,
Okay.
I'm not sure. Let me see. This one I think is today the soccer. That would be the lowest common multiple.
Okay. So when will both teams have games on the same day again? Yeah. Okay, because you're looking for a point of overlap when they'll meet again. Okay, that's LCM. All right, so we're back to number 5 now. A car dealer has 20 Toyota Camrys and 25 undercards left on the parking lot. The dealer wants to arrange the cars in rows so that each row have the same number of vehicles and the same number of vehicles of each type. What is the greatest number of rows that can be formed? What do we say on that one?
That's greatest common divisor.
Yeah, okay, yeah. All right, we're trying to divide it up into smaller groups. Okay. All right, very good. All right, so that basically brings us to the end of the activities for the class. So your homework is here, page 94, and the questions are listed from 1 to 47. I copied the questions here so you could identify the ones you need to do. And hold on, 94. Let me see, 94 next. No, 47. Okay, 1 to 47. Okay. So 45, 47 is here. Okay, and then for section 5.1, page 235, you have 1 through to 95, but just selected questions. So I have the questions here. All right. And then the answers are here. That's the answer for 2.5 and the answers for 5.1. Okay, so discard. Yeah, okay, discard that. Okay. All right. So if you check your email, you should see 3 emails from me. So the first one was, I think, the test that we did last class. So I want to go through that now. Let's see. Let's see. Where's that? Okay. Mhm. Okay, so for question number 1, you all should see a copy. Oh, you should have the copy because you wrote on your thing, but okay. So for question number 1, I see I only, okay. There are a number of ways you could have answered question number 1 to get the full marks. So I think one person, I only gave 1 point because you just put natural numbers, 1-8. You have to be a little more descriptive. Okay. So if you put natural numbers from 1 to 8 and inclusive, okay, the persons who got the full 2 marks, one person said natural numbers from 1 through 8. The next person says a set of natural numbers from 1 to 8. Now and then the person, somebody put a set of natural numbers. That's not specific enough because a set of natural numbers could go to 1 million, a trillion. You have to specify the set of numbers, natural numbers less than 9, the set of natural numbers less than or equal to 8, the set of natural numbers from 1 to 8, but you have to be specific so that anybody who sees this description, that's the only thing they could put. If you say a set of natural numbers, it could be 100 numbers in that set. It doesn't specify, okay, what you are looking at. So that's not specific enough to get points for that. Okay, if you want to even say the first 8 natural numbers, well, the first 8 natural numbers would be 1 through to 8, but it have to be specific. Question number 2, it says express each set using the roster method. For question number 2, the answer should be open bracket. I think most of you, let me see, everybody got, yeah, all of you only got, oh, one person got 2 points, but everybody else got 1 point because you repeated the n. The n doesn't need to be repeated. Once the term is there, the element, you don't need to repeat it. And put a comma. I think, let me see, one person didn't put a comma. I still give it a point, but you should put a comma between each element. So if you want full marks, do not repeat members and make sure to put a comma between each. Okay, for question number 3, let me see. Everybody got that right. Number 3, no. Somebody missed 7. Somebody missed 7 in number 3. Okay, number 3 says greater than or equal to 7 and less than 15. So 7 has to be in that one for number 3. Question number 4, the answer is no. Let me see if everybody got that. Okay, one person didn't get that. The answer is no. And the reason for that is because, let me see, determine if the given, hold on. Hello? I hope they didn't end the lesson. Are you all there?
We're here.
Oh, okay, okay. Because I know sometimes they want the link for another class. Okay, yeah. So, okay, so question number 4 says determine if the given set is empty. That set is not empty. It has a member in it. Empty set is either the brackets without anything in it or the 0 with that stroke across. So that should be no. Question number 5, let me see. 93 is not a member of that set. So the symbol you should be writing is not a member of. It's not an element of, because 93, if you look at that, it's 2, 4, 6, 8, 10, 12. Those are even numbers. 93 is not an even number. So even though it falls within the range, it's not in the pattern. 93 is odd, and the numbers listed there are even. So you have to be careful to look at that also. Question number 6. Let me see. 6. 6. I think most people got that. Number 6. Let me see. Number of members is equal to 7. I think one person put the 7 in brackets. And I did show that it should not be put in brackets because you're just telling the number of members in the set. You're not asked to list a set. Okay. Number 6. Number 7 is not equal to. Okay. Those two sets are not equal. X is greater than 7. Goes on and on and on. So the set of all x such that x is a natural number and x is greater than 7 starts with 8, 9, 10, 11, 12, 13, but it doesn't end. Whereas the other set that starts at 8, it ends at 100. So the two sets are not equal. Okay? One is an infinite set and the other one is finite. It stops at 100. So those two sets are not equal. Okay, question number 8. That was for 1 point. Let me see, everybody. Okay, one person put true, but the question didn't ask you to say whether it's true or not. It just asked you to say if the sets are equivalent, equal, both, or neither. All right, those sets are equal and equivalent. Okay, because the set of the set of x such that x is a member of the set of natural numbers and x is greater than 3 and less than 7, that's 4, 5, and 6. And B is 4, 5, and 6. So they have the same number of members and they are equal. So both would be applicable, either equivalent. It has to be equivalent and equal. Okay, question number 9. That's an infinite set. There's no end. It goes on and on. Okay, so all right. Question number 10. They want you to put is a subset or not a subset. Number 10 is a subset. Okay, penny, nickel, dime. Penny, nickel, dime. Yeah, penny, nickel, dime is in that second set, so it is a subset. Question 11. That's also supposed to be a subset. The empty set is a subset of the set of odd natural numbers. The empty set is a subset of all sets. So that's true. That's should be the subset symbol. Question number 12. Determine whether subset or proper subset or both is applicable for that question. And for that question, it is not a proper subset. So only the one with the stroke under, which is the first symbol, should be correct. So that's number 12. Let me see what persons have there. 12. Okay, one person have it right. The person, okay, somebody have it wrong. Okay, 12. Okay, so two of you had it incorrect. All right, determine whether or not each of the statement is true or false. Okay, 13 is false, 14 is true, 15 is true, 16 is false. Okay, number 17. Now, in the case of number 17, I think we had to cut class a bit short that day, so we didn't really spend the time with that one. But when you're asked to list all the subsets of a set, definitely two sets you should include: the empty set and the set itself. So in your answer, you should have the empty set, then you should have the set itself, then you're going to list all the subsets with just one member. So you're going to have 5 as a set, 7 as a set, and 9 as a set. Then in this case, you have also sets with 2 members. So you're going to have 5 and 7, 5 and 9, and 7 and 9. So those are all the subsets. Did I write them? Let me go back to share screen. I need somewhere to write. Let me see. Okay. Okay. Excuse me a sec there. I'm trying to get a place to write some stuff so I could show you. Let me see many of my apps. Word in this. All right, let me see. This. All right. I'm going to use one of these slides, I guess. Some space. All right, I'm just using this to show something. So for 17, so you should, are you all able to see the screen? Hello?
Yeah, speaking to you.
Okay, all right. So it should be 5, then 7, then 9, then 5 and 7, then 5 and 9, then 7 and 9. Okay. So these are the ones with one member. These are the ones with 2 members, and then the empty set, and then the set with all the members, which should be 5, 7, and 9. So altogether you have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 subsets. So anytime you have a set with 3 members, you should be able to get 8 subsets. And the formula, which is in your book, says that to find the number of subsets you could get for each set, it's 2 to the power of the number of members you have in the set. So if a set have 3 members, then 2 to the power of 3 is equal to 2 times 2 times 2, which is equal to 8. So it tells you could have 8 subsets. All right. So if I had a set with 4 members, 2 to the power of 4, 2 times 2 times 2 times 2 equals 16. I could get 16 subsets. And the last question, number 18, they ask you calculate the number of proper subsets for a set with 5 elements. So a set with 5 elements, you could get 2 to the 5th, which would be 2 times 2 times 2 times 2 times 2, which is equal to 32. So I could get 32 subsets, but they don't want all the subsets. They want the proper subsets. So the only set that would not be proper would be the set itself. So every set has one subset that would not be proper, and that's the set itself. So I would have to subtract the set itself. In this case would be 1. So 32 minus 1 equals 31. Okay. So if the question just wants you to say how many subsets, 2 to the power of the number of members in the set would give you the number of subsets. But if I said a proper subset, then I have to subtract 1 to account for the set itself, because the set itself is not a proper subset. So that's why the answer for number 18 is 31. Now, if you just put 32, you'd only get 1 point for working out the number of subsets, but you wouldn't get the point for stating the fact that you have to subtract the 1 for the set itself. Okay. Any questions with any of those? Do I need to go over anything? Because I sent you another test. It's very similar to that one, and you need to get a 90% for me to credit you with, what I'll do is average that one with this first one to improve your score. So if you get 100, and let's say you got 40 for the first time you did it, 100 plus 40 is what? 140 divided by 2, 70%. So I don't want to give you a test and you still end up getting 40% or 50% the second time. You must get 90% or higher for me to credit you. If you get less than 90%, you're going to keep your old score. I wanted to take it seriously and go through it. If you have any questions, right now is the time for you to ask if you're not sure about any of the questions. And so you could be sure what you need to do to get at least 90%. In fact, you should be getting 100%. But I say, I give you 90 because you're taking it home. You're going to do it. And I know tomorrow is no, not tomorrow, Monday. Monday is Valentine's. So, but I still give you till Monday to get it to me. Because I know some of you might have to print it if you don't have a printer at home, but I need you to print it, write the answers on the printed copy, and either take a picture or scan it back to me by Monday evening, so I could mark it and adjust your score in time for next class. What else did I send to you? Okay, I did send the PowerPoint presentation to you. Yeah, so I think you should have all that you need for your homework and so on. Okay. Any questions? We all clear?
Well,
Okay. Let me see. Exit full screen. Okay, so Ms. Fernanda, that was you who answered me just now?
I was Nairn.
Yeah. Okay, Ms. Fernanda, you all clear? Any
Yes,
questions?
clear.
Okay. Miss Nairn, you answered me already. Miss Pratt? Miss Pratt, are you there?
I'm here.
Okay. So you clear?
Yeah, I think so.
You think so? Ask the question now, Miss Pratt, before we go. Yeah.
I don't have any questions at the moment, only like when I'm actually sitting down going through the work. I can't say anything off the top of my head.
Okay, but you look through your tests and you understand what you got wrong, if and what you could have done?
I don't know what went wrong, but I'll see.
Yeah, but what I'm saying, as I was going through, were you making the correcting it and so on?
No, I didn't make any correction.
Oh, that's why I was going through it, because I wanted you to. Okay, so but you think you should be able to figure it out. That's what I'm saying. Before
Hopefully, if not, you'll hear from me.
Okay then. I don't see Miss La Rochelle. I guess she left. Okay. All right, so that's it for now. And if you have any questions, well, you could send me an email, and I'll make my best to answer you. Okay. Bye-bye until next time. Okay
Okay,
then.
good evening.
All right then.
Good afternoon.
Good afternoon.
Good afternoon then. Okay. One of this. Stop share. And